Greetings, Patriots. Don't forget to get yourself set up with your I do and we do problems. Now what we will be doing in this particular lesson is writing and solving one-step inequalities and graphing on a number line, but using only positive integers when I give you a situation and using our strategy that we used with equations to solve. Okay? So let's go ahead and look at this first problem together. Okay? So we know that Sani has at most 68 envelopes to address, okay? And he has addressed 17 of them. So we need to write and solve an inequality that describes how many more envelopes, right, at most that he has left. So there's that key word. Remember, we talk about use your symbol vocabulary. So when I go to my symbol vocabulary, at most means less than or equal to. Okay, so the most that he can address has to be less than or equal to 68. Well, he's already addressed 17, so he has so many more that he actually has to address. So those envelopes is your variable, what we are looking for. Okay, so here we go. What we're going to do is the following. We know that we're adding here, so what's the inverse of addition? Subtraction, right? So I want x by itself. So remember, I'm going to do the inverse of that. So I need my 0 pairs. What I do to one side, I do to the other side. I get my 0 pairs, and therefore I end up with x is less than or equal to 51. So that means, right, how many more envelopes will he need? Well, he's definitely going to need 51 more envelopes. So if I check my solution of 51, if I add 17 plus 51, is that less than or equal to 68? Well, when I check that, 68 is less than or equal to 68. That means that that solution keeps this inequality as a true inequality. Let's go check another number of envelopes. So let's check 50, right? So it has to be less or equal to. So 17 plus 50, when I add that, that gives me 67. Is that less than or equal to 68? Well, it is less than, so my inequality is true. So that means that my solution set must be a number that is 51, 50 envelopes, 49 envelopes, 48. Anything that's less than 51 makes the inequality true. So if I think about the number of envelopes, I know I don't have a lot of room, but I definitely can have 51 envelopes that still need a stamp, okay, or need to be addressed. So I can also have 50, I can have 49, I can have 48, etc., right? So I have a solution set that is 50 or only numbers, any numbers, less or equal to 51. Okay? All right, let's go ahead and try another one together. Here we're looking at Nadine, who can send or receive a message. Oh, that should say 10 cents each. So go ahead and make that correction on your notes. I must not have caught that. 10 cents each, or get an unlimited number for $5, right? So trying to make a decision. So we need to write an inequality to determine how many of the messages that she can send and receive so that the unlimited plan, that $5 plan, right? $5 is less than, is cheaper than paying for every single message. Well, 10 cents every message. Here we go. Okay, so there's my inequality. I want to know when the unlimited plan, so I'm looking at my unlimited plan, when it's cheaper, right? When it is cheaper than paying every single 10 cents for every message. So we're going to solve this like we normally would. I know that this says 10 cents times the number of text messages, so I'm not going to multiply. That means I need to divide by that coefficient. So if I divide by 10 cents on both sides, and I take 5 and divide it by 10 cents, that means that the text messages have to be greater than 50. So remember, I'm looking to see after how many messages. Well, when I read this, I can read from my variable. Remember, we've talked about this in class. An inequality can be read left to right or right to left. We are making a comparison. So this says that when my text messages are greater than 50, right? When they're greater than 50, it's going to be less expensive to go with the unlimited plan. So I'm going to test some numbers here. I'm going to test what are numbers that are greater than 50. Well, 51 messages, 52 messages, 53 messages, etc. So let's test it. If I have $5, I want to know, that's my unlimited plan. What if I use 50 cents? I'm going to go with that, right? If I take 10 cents and I multiply that by 50 cents, 50 text messages. I apologize again. Okay? So I'm taking 10 cents and multiplying that by 50 times 50 messages. Well, that's going to give me $5 exactly. What does that say about the unlimited? That says that the unlimited is equal to that. So 50 messages makes this a false inequality. So let's check, right? It says greater than 50. So here's my $5 unlimited plan. Let's take, what if I send or receive 51 messages? So I'm going to take 10 cents and I'm going to multiply it by 51 messages. Well, when I do that, that's $5.10. There we go. So the unlimited plan is going to be less than, right, if I pay per message. So this makes this inequality true because $5.10 is greater than 5. Okay? So my solution of x is greater than 50 has to be true. So when I graph this once again on my number line, here's 0. I'm just going to kind of skip to 50. Anything beyond 50, so I'm not including 50, but anything to the right of 50 will ensure that the unlimited plan is going to be less after, you'll start, if you're going to send more or receive more than 50 messages. Okay, let's do one more problem together, and then you'll have an opportunity to join us tomorrow on Zoom, and you should also attempt to work on the we do problems. All right, Becky wants to buy some fish for her aquarium. She has $20 to spend. That's all she can spend. That's a clue right there. That means I have to stay under budget. And the fish are costing $2.50 each. Write and solve an inequality to determine how many fish Becky can afford. So they're $2.50 each. There we go. $2.50 for every fish. I need to stay under 20. Okay, so this has to be less than or equal to 20 because the most I can spend is $20. So as we look at that, once again, my operation here is multiplication. I'm going to divide. My key word was, right, can afford. So I need to be able to afford this. Can I afford it? Okay. Also, she has $20 to spend. So that lets me know that she is limited to what she can spend. So I'm not going to multiply by 250. I'm going to divide by 2.5, which is the same thing on both sides. So when you take 20 and divide it by 2.5, you get that the amount of fish, this is looking at the number of fish that Becky can afford, that she can afford has to be less than or equal to 8. So let's test that. $2.50 times 8, if you put that in your calculator or multiply it out, you get 20. Is 20 less than or equal to 20? Yes, it is. Good. Okay. So now let's go ahead and check. That makes that true. That we're just checking to see if our solution set is correct. If I take 2.5 and multiply it by 7, fish, $2.50 times 7 fish, that's going to give me $17.50. Is that less than or equal to 20? I'm going to say that that's true. It is less than or equal to 20. So therefore, the number of fish that I can buy have to be 8 or less. So notice, I am not shading anything here because we've talked about having a discrete situation, right? So it's important that you understand you can't buy 7.5 fish, right? So these are the number of fish. Anything that is less or equal to 8 will keep me within my budget. All right, we will talk a little bit more about this. Don't forget to always attempt the we do problems that are given to you, and you'll have a little I do problem to work on so that we can check for comprehension. Have a great day.